And we've actually done 6.2, so we're going to take a quick look at that. All right, Kervin, you okay?
Yep.
All right, so these are the people I need to get calculators back from. So, all right, now, on the last time we were together, and you can either write this down somewhere in the margin of your notes or another sheet of paper. This is not on your note sheet. But the big deal on Friday was we learned how to find the angle between two vectors. So, for example, vector A, which is -1, 3, and vector B, which is 7, 2. Does anybody remember the little formula I gave you that we use to find the angle between two vectors? Equals dot product. So the dot product equals magnitude times cosine. Remember that? Dot product equals mag times cosine. So, first thing I'm going to do is find the dot product. So here are my two vectors. Who remembers how to do that? Yep. X times x, y times y, add them together. So x times x, let's see, I'll do it over here to the side, a dot b, the dot product will be x times x plus y times y. So what does that work out to be? -1. So my dot product is -1. X times x, y times y, add them up. Now, magnitude of the first one. Remember, you can draw this if you want, or you can just do the Pythagorean theorem. You know it's going to be 1 squared plus 3 squared. So that would be the square root of 10. Remember, when we do the Pythagorean theorem, we do not worry about negatives because they get squared out. So don't get confused. They're gone. 1 squared, 3 squared. Add them up, take the square root. All right, what about this one? Same thing. What's the magnitude of this guy? The square root of 53 times the cosine of the angle. That's what we're looking for. Find the angle. That's the question. So, do you remember what I did next after I got this set up? Dot product equals magnitude times cosine. Yeah, I put these two together so they were one number instead of two. So 10 times 53, that'd be 530. And then what do? We divide. And then the buttons that we press on our calculator are second cosine. So I gave away my calculator. So Quincy, what's second cosine -1 over the square root of 530? You have my calculator. Yep, good idea. Works better if it's on. Everybody has a calculator and should be practicing with this. 92.48. Anybody match that? 49. 92.49. So that's how we find the angle between two vectors. That was the big message the last time we were together. Finding the angle between two vectors. That's a big deal. Okay? Now, the only thing left for us to talk about is in 6.3, part 1 and part 2. That is all we're going to talk about. And we're going to start reviewing again. The next time we're together, we'll start reviewing again. So here we go. Problem A, 6.3, 1A. Eliminate the parameter, identify the curve. You have already done problems like this back in, I can't remember what chapter it was, maybe chapter 1. We did problems like this. Does anybody remember how we do this, how we eliminate the parameter? Okay, it's like substitution. So, I want to get t by itself. Which equation would be easiest to get t by itself? The top one? So that top one says x minus 1 equals t. Would everybody agree with that? Now I'm going to take that x minus 1 and I'm going to plug it in to the other equation. So y equals 3 minus 2 times x minus 1. So y equals 3 minus 2x plus 2, which, to make it look like I like to see them, negative 2x plus 5. What is that? Well, I did substitution to find it, but what is this is a line. Isn't that y equals mx plus b? So when the directions say, for part A, or letter A, 1A, eliminate the parameter, done, parameter gone, the parameter's t, t's gone, and then identify the curve, this is a line. That's what it means when it says identify the curve. What shape is it? Oh, that's not too hard. All right, let's try B. In a minute, we're going to graph these on our calculator, so hang on. But right now, let's do B. Okay? So eliminate the parameter, and then tell me what shape it is. All right, what are your thoughts here? Eliminating the parameter. We need to get t by itself. Which equation would be the easiest? Well, they're both easy, but maybe the bottom one, because then I don't have to mess with the negative, right? That negative messes me up sometimes. So this bottom one says what? Y minus 3 equals t. Everybody okay with that? So then we'll take this right here and put it here. So x equals 2 minus y minus 3. So x equals 2 minus y plus 3. Don't forget to distribute the negative. Or x plus y equals 5. Or y equals negative x plus 5. I don't care which way you write it. Any of these three is okay. But when you write it this way, then you very clearly see y equals mx plus b. So this is another line. I don't care which of these forms you use. All these are fine, but you have to recognize it's a line. So put it in whatever form you can see that. Got it? Everybody's tired today. All right, let's do C. It's a little more exciting. Because what does C have in it? Squared. Oh boy. All right, so here we go. We're going to get t by itself. Not up here. I'm not going to do the square root stuff. We're going to do it right here. All right, so here we go. See if I add t and subtract y, t equals 2 minus y. I did that in 2 steps because I wanted to make sure I got it right. Now, what am I going to do with this? I'm going to put it right back in up here, right? Make sure you plug it back in the other equation. So x equals 2 minus y squared. you can actually stop here because you've eliminated the parameter. What does that mean, eliminate the parameter? It means make sure you don't have t's in your answer. But you have to identify that curve. Can you identify it here, or do we need to do some work to it? Can you think what that is? It's a parabola. This is a parabola. Do you remember when you have a squared in your equation, it's a parabola? Okay, we're going to graph this on our calculator, so I need everybody paying attention. You need to be pushing the buttons I'm telling you to push, okay? So the first thing I want you to do is go to mode. Okay? Everybody in mode? Now, I need you to go down to where you see the PAR. PAR stands for parametric. And we are going to graph these two equations. You've decided it's going to be a parabola. We're going to check and see. So everybody in parametric mode? While we're there, would you go ahead and make sure you're in degrees? It doesn't make any difference. I just want to make sure we're all the same. Okay, so we're in parametric, PAR, and we're in degrees. Okay? Now, go to your window. Okay, you got your window there? I want you to go where it says T-min and T-max. I want you to go from 0 to 360. Now, remember how I had you set your calculator in degrees? 0 to 360 is what? A whole revolution. So I want to make sure I get every value. So I'm going 0 to 360. All right, and then where it says T step, I want you to make that 3. Where it says X min and X max, let's go with, let's try negative 100 and 100 for X min and Y min. I may need to fix that, but let's try it. For X min, X max, negative 100 to 100. Y min, Y max, same thing, negative 100 to 100.
What about the Y scale?
Just leave them at 1. The scale should always just be at 1. Now we're going to put in our equations. So go to Y equals, okay, wait a minute. What's that asking me for? An X equals equation and a Y equals. So press T squared, and T is on your variable button where you get your X, right under your mode button. If you press that, a T will come up. And then your Y equation is 2 minus T. Make sure you're doing 2 minus. Well, I've got a bad window. I need to fix my window, so I'm going to check it. I'm trying to get my window set right. There we go. I'm getting closer. There we go. Okay, here's the window I want you to use. It just takes some playing around. For your T-min and max, I need negative 360 to positive 360. My X-min and max, are negative 100 to 100, just like I had before, but my y-mins, I'm going from negative 10 to 10. So try that. Negative 360 to positive 360, negative 100 to 100, and negative 10 to 10.
And then
Try
all
that.
that graph.
Then hit graph. And you should see a parabola.
Wait, what do you put? Sideways?
Sideways. Yeah,
Oh.
it's a sideways one. Okay, so one more time. I want you to, if you don't have the right picture, I need you to stop pressing buttons, and I need you to do exactly what I tell you to do. Go to mode, press the mode button. Make sure you have degrees highlighted. Make sure you have PAR, parametric highlighted. Go to your window. Set your window exactly like I have it here. Negative 360 to 360, negative 100 to 100, negative 10 to 10. Go to y equals. Type in these two equations exactly like I have them written here. Type in t squared where it says x equals, and type in 2 minus t where it says y equals. Then hit graph. And you should see a parabola opening sideways. Now, why is that a big deal? Well, have you ever seen a parabola opening sideways on your calculator before? No, you haven't. The only parabolas you've seen on your calculator are parabolas that open up and down. Because this one is not a function, and your calculator won't graph things that aren't functions unless you put your calculator in a different mode. Okay? All right, one more problem. Here we go, then we'll try to graph this one and see what happens. So, let's go. Let's rewrite this without the parameters. We're going to eliminate the parameter. X equals t plus 1, and y equals t squared minus 2. All right, how do we eliminate the parameter? What do we do? This is problem D. Yep, we're going to subtract 1, so x minus 1 equals t. And then we're going to take that and put it right here, right? So we're going to have y equals, parentheses, x minus 1 squared, because that's t, and we're squaring the whole thing, minus 2. Now, you can leave it like that if you want to, or you can FOIL it all out if you want to. Can you tell that's a parabola?
Yeah.
Yeah, because it has a squared. Now, I'm going to type in these new equations. I'm going to leave my window alone for a minute. I may need to change it. I'm typing in the original equations. T plus 1 and t squared minus 2. Now I'm going to hit graph, and I have no idea what's going to happen. Yep, I need to change my window. There we go. Okay, what I did was I just flip-flopped these two. So my x's went from negative 10 to 10, and my y's went from negative 100 to 100. And that should show you a parabola. And what about this parabola, if you make that change? It's up and down. This is an up and down parabola. So I just changed my window. So these were the x's. And these were the y's.
So like if we're taking a test one, we just have to like keep playing around with it.
Yep. Did you hear what Deshani just said? Now listen, I am ancient. I have done bazillions of these problems in my life. And what do I still need to do? Play around with it, trial and error, mess around with it till I get a picture. You already knew it was supposed to be a parabola, so you just keep messing with it until you get something that looks like a parabola.
Is the man always going to be negative or?
It doesn't have to be, but it almost always is. Whoa, why are we packing up? We're not done. Whoa, we got a whole other section to go, people. No, you didn't. I'm not sure he's out of the hospital. Of course, he might call in. Who knows? I went to visit him yesterday. He's doing well. He says he has ulcers because of you guys.
Wait, was he in the hospital?
He has ulcers.
Who?
All right, so here we go. 2A. We're going to get this one done. 2A.
Stop.
You're going to write the parametric equations of the line through the given points. Okay? Now, look back at problem number 1A. Those were a line. These were parametric equations of a line. I didn't write it down. This is 1A. What was the answer to 1A? What did we get as an answer? Y equals negative 2x plus 5. I want to show you something. These are the parametric equations of a line. They're always going to be x equals something plus something t. Y equals something plus something t. These are the parametric equations of a line. Now, look at problem 1A. Do you see how the coefficients on the t are negative 2 and 1? Do you see how the slope of the line is negative 2 over 1? That's not a coincidence. Y over x gives me my slope. So when I look at these 2 points, first thing I'm going to do is find the slope. 2 minus negative 4 over 1 minus 3. Y minus y, x minus x. So that's 6 over negative 2, or 3 over negative 1 if I reduce it. That automatically tells me that in these 2 boxes go a slope of 3 over negative 1. Now what you have to be careful of is put the 3 in the right box and the negative 1 in the right box. Remember, slope is y over x. So the 3 is going to go here and the negative 1 is going to go here. Always, always, always your slope goes in the t boxes. And when you put your slope in there, it's got to be y over x. Okay? Now, here's the happy part. What goes in these boxes is either one of those 2 points. So I'm just going to pick 1, 2. And there are my parametric equations.
That's stupid.
The t boxes get the slope. The other boxes get one of the points. Either one. Use either one, doesn't make any difference. Okay? Now, if your name is on the board, I need you to